We've been talking about the evidences for a theistic God. And what we're doing is we are asking 4 questions. We are asking, first of all, does truth exist? And that was the first couple of weeks. Then we're asking, does God exist? And then we're going to go on to, are miracles possible? And finally, is the New Testament true? So, last week we started, does a theistic God exist? We looked a little bit at some of the different types of conceptions of God. We learned that there's basically 3. There is one concept of a God who made all. We would call that a theistic God. That would be, examples of that would be Islam, Christianity, Judaism. They all say a pre-existing eternal God existed who set everything into motion and made everything. Then there is what we would call pantheism, which is God is all, or God is in all. And that's kind of like the trees are God, and the cows are God, and the grass is God, and God is just everywhere and in all and is all. And then there is atheism, which is there's no God at all. And the major religion of atheism is something that we would call secular humanism, or religious humanism. And what we're going to do is we're going to explore 3 major arguments for a theistic God. And we just started that last week. The first argument is called the cosmological argument, and that is the argument for the existence of God from beginnings. We're also going to look at the teleological argument, which is the argument of a theistic God from the design that's in the universe. And finally, the moral argument for the existence of a theistic God. So today we're going to tackle the cosmological argument, and we talked about this last week, where the logical argument goes very simply like this. Everything that had a beginning had a cause. That is not something that we have to prove. That is a self-evident statement. Nobody sees something coming from nothing. When we see something, we know that there was some kind of a cause for it. It may be a natural cause, or it may be an intelligent cause, but there is some kind of a cause for anything that comes into existence. The second premise is that the universe had a beginning. And our conclusion is, therefore, the universe had a cause. That's all we're looking at right now. Now, the universe had a beginning. That is the crux of this argument. If that is not true, then this may be a valid conclusion, but if the premise is not true, then this may not be true. If, however, premise 1 and 2 are true, then it follows in a valid logical argument that the universe had a cause. So we started to look at the scientific evidence that I don't know what's going on.
It's not one to go forward.
You went backwards.
I'm sorry.
No, you're fine. There we go.
So last week we looked at the second law of thermodynamics, and we talked a little bit about what thermodynamics was and why the second law implies a beginning of the universe. And I won't go over all of that from last week, but basically the second law of thermodynamics says in a closed system, which the universe is a closed system. The universe is a finite system. It is not an eternal, infinite system. That in a finite system, the amount of energy that you have can be neither created nor destroyed, first law of thermodynamics, and that as you can go from one form of energy to another form of energy, but in that you lose usable energy. Okay? So as an example, you've got a candle, it is burning, it's got a certain amount of energy that's in the wax and in the substance of the candle. You light the wick, the wax starts burning, and it turns into a different form. It is no longer wax that has burned. You add a little oxygen from the air, you've got the heat, and all of a sudden you have light, which is a form of energy. You have heat, which is a form of energy, and you have smoke. So you convert the wax substance in your candle into heat, light, and some debris that is the smoke. So you've changed the forms of energy. Now, you can't go in and grab the heat and grab the smoke and smush it back into a candle again, okay? We lose usable energy, okay? You've converted it, and you can capture some of that energy. You can capture the heat. You can use that, for example, to heat up a pot of water, okay? You can use that heat, but the amount of usable heat as you burn that candle dissipates. You go from order, the order of the candle, to disorder, the chaos of the heat and light that kind of dissipates in this universe. So the second law is saying is that the amount of usable energy from the beginning must be burning up. We can't capture it all. You got usable energy going into unusable energy. And here's the point of the second law of thermodynamics and a beginning. If you have had an eternity to burn all your fuel, you would have no fuel left. When we look out in the sky and we see the stars burning, we know that we have fuel left in the universe. Therefore, it cannot be an eternal universe. It had to have a beginning from which we are burning out, but we haven't burned out yet. Okay? That is the implication of the second law of thermodynamics. It doesn't make any sense at all that we have an eternal universe if we've still got usable energy in this universe. Does that make sense? So the next good argument for a beginning is the universe is expanding, and that's where we left off last week. The universe is expanding. So what this says is if we look out at the sky and we see that the universe is expanding, then what makes sense is as we see this expanding universe, if we just take time and dial it backwards so that we look at it 1,000 years ago, it might be this big. If we look at it 8,000 years ago, it might be this big. 20,000 years ago, this big, and so on and so forth. If we dial back, we see that the universe is expanding from a central point, and we just dial back time to see that it collapses back down into nothing. Now, the way that this was discovered is by a guy named Edwin Hubble that we're going to look at. But first, we have to talk about the Doppler effect. Does anybody here know what the Doppler effect is? Okay. What's the Doppler effect?
The best example is, I see you got a train up there.
Yeah.
If you go sit by the railroad tracks and you hear the train coming.
So the train's coming over here.
And blowing its whistle. As it passes you, its tone changes because the sound waves are going away from you now instead of coming toward you.
Right. Perfect. So we've all been stuck at the on Howard Street or Walnut when the train has come, and the train is blowing its horn, and it has a particular tone. It's got a higher tone as it's coming towards you, and then as soon as it passes, that tone goes way down into a lower tone. And the reason for that is something called the Doppler effect. And we're going to look at that. So here's the police car. It has passed the girl and is going towards the boy. Now, sound travels at a very specific speed. At sea level, sound travels at 768 miles per hour. If you've got a police car that's traveling 50 miles an hour and the sound is going 768 miles an hour, that means that the sound that is hitting this boy's ear is going 768 plus 50 miles an hour. If we throw a ball from a moving car at 50 miles an hour and the car is going 50 miles an hour, that ball is going to go 100 miles an hour. Okay? Same with sound. Sound is traveling at 768. The car is going 50. That means that when it reaches that boy, it's traveling 818 miles an hour, not 768 miles an hour. Okay? It's hitting that ear faster. Now, sound is a wave. Okay? So if you think about that wave that goes in very specific intervals, the wave is very consistent. But now you speed it up, it's going to be hitting his ear at a faster wavelength. Okay? Because if there's a particular wave that goes at particular intervals, but it's moving faster, it's going to hit your ear faster. That's what is meant by these shorter waves here, these shorter lines. Whereas if you're traveling 768 miles an hour in one direction, okay, so sound is going that way as the train is going this way. Okay, now the sound waves going that way are traveling 768 minus 50 miles an hour. So they would only be traveling 718 miles an hour. So our ear, as it hits it, is going to hear those waves slower than the ones that are in front. So that is why, as the train goes away, slower means less frequency, means lower tone. Okay? Because the tone is related to frequency. High tone is high frequency. Low tone is low frequency. So it sounds high-pitched coming at you. The sound waves are actually going faster, so the waves are hitting you at faster intervals, and you hear a higher pitch. It's going away. It is now going, that sound is hitting your eardrum 100 miles an hour slower as it comes back to you. So all of a sudden the pitch drops. And that is what the Doppler effect is. So,
what's it sound like?
why don't you demonstrate? Go ahead.
Right? Because if you think about how the train, I mean, you do it.
No.
Right? So in an ambulance is the same, or a police car, right? You go
Yeah.
as it goes, right?
Right.
And it does. It seems to change right when it passes you.
Exactly. So that is the Doppler. So in 1929, Edwin Hubble is in California, and he has got one of the best telescopes available, technologically available at that time. And he is looking at the universe, and he discovers something. He figures out that when he is looking at stars of distant, at distant places in our galaxy, he realizes that the farther the star is, the more of what we would call a red shift is going on. Okay? A red shift is what we just talked about. It's the Doppler effect with light instead of sound. Now, light emits a wave, okay? And depending on the frequency of the wave, we see a different color, okay? Low waves are more towards red, and higher waves are more towards, what? I can't remember.
Purple,
Maybe purple. I don't know. I can't remember.
ultraviolet, right?
Yes.
Ultraviolet or long
Okay.
waves.
Violet, yes,
Infrared
that's
is
right.
for-
So what he noticed is that as he looked at stars that were closer to us, they had a red shift. Red shift means that the light that is actually hitting our eye shifts to the red, which is a lower wavelength, which means that that light coming from that source is moving away from us. Just like the train going away leaves a lower pitch, a star that's moving away from us is going to hit our eye with a lower wavelength, which makes it shift to the red, because red is lower wavelength. And what he notices, the farther out that he looks, the greater the red shift. And he said, oh my gosh, what this means is that it's not just we're moving relative to one another, but the whole universe, as I look out farther and farther, the red shift gets bigger and bigger. The whole entire universe is expanding. And he sat there and said, ooh wee, this has some serious implications for the beginning of our universe. So we're going to talk about this a little bit later, but Edwin Hubble then called up Albert Einstein and said, hey Al, you need to come take a look at this. This might have some bearing on this work that you're doing on general relativity that we've been talking about. And we're going to talk about that in a few moments. So anyway, Edwin Hubble in the 1920s discovers that the universe is expanding through recognizing that there is this Doppler effect, this red shift. And the farther out he looks, the greater the red shift, which means it's not just one star that's moving away from us. It's the whole entire universe is expanding and moving away. The next discovery is called the radiation afterglow. That's what the R is. And this was discovered by two guys named Penzias and Wilson. Now, I have to give you a little bit of a background. So in 1929, we realized that the universe is expanding. And all of a sudden, the fact that if you dial this backwards in time, that we would have had a beginning possibly from nothing, that the universe actually was non-existent and began to exist, started to get into the minds of scientists. So we're talking in the 1920s, 1929. Well, that has huge implications, and people start thinking a lot about that. And so they're sitting there and imagining what it would be like for the universe to explode into existence. And guys a lot smarter than me started to calculate that if that happened, we should expect to see this radiation afterglow. You get this monstrous, I mean, just inconceivable, massive explosion of nothingness into somethingness, and even at the beginning, no galaxies were formed. We're talking just hot matter of protons and neutrons and electrons that weren't even hooked up into atoms at this point, exploding into existence. And so calculations were made on what we would expect to hear in the universe from this giant explosion. In other words, we should be able to detect some echoes of this giant explosion today. Scientists were on the look for it, and they couldn't find it. They were theorizing about this until these two guys came along. Now, these two guys worked for Bell Laboratories, and they had this satellite that they were working on. Let's see, yeah. In 1965, they were testing a new satellite, and they were testing it for commercial satellite communications in 1965. And as they pointed their little, this is in New Jersey, and as they pointed out to the sky, they started getting this this background noise. They didn't like it. They wanted to get rid of this background noise, and so they pointed it to a different part of the sky, and they still heard this background noise, and they pointed it to a different part of the sky, and they still got, no matter where they pointed this thing, they got this background noise. And they said, it must be the pigeons and all the droppings. So they climbed into the bell of this thing, and they got their things, and they swept out all the pigeon droppings, and they cleaned it up, and they just gussied it up and checked all their connections, and they pointed it to the sky. Same interference. Now, this really bothered them because this is an early communication satellite, and you don't want a bunch of static in your communication satellite. So they called up these guys at Princeton, and these guys at Princeton were just launching, they were getting their money together to launch the search for this background radiation. And when they called these guys at Princeton and said, we've got this strange little thing here, this group said, we know exactly what you mean. And you know what's kind of funny about that is because they actually did. They found the background radiation from the initial creation event. The little background, they were working on these scientific calculations 20, 30 years at Princeton in their physics department, and they said we would predict that we would get this background 3K radiation noise, and they found this background 3K radiation noise, and they came and looked at their data and said, you have no idea what you just found. So these brilliant minds down the road here, these two guys here, they're little accidental, they're just kind of working on their thing, sweeping out the pigeon droppings. These guys get a Nobel Prize, and all those Princeton guys got nothing.
You got nothing.
Poor students.
So, no other explanation other than the Big Bang has been found for the fireball radiation. The clincher, which has convinced almost the last doubting Thomas, is that the radiation discovered by Penzias and Wilson has exactly the pattern of wavelengths expected for the light and heat produced in a massive, great explosion. So, the next thing is after this discovery, you have to remember, if you've got this explosion, and you have to remember, no atoms are in this thing. The heat's too great, nothing is together, and what happens is, as it goes out, as you get farther away from an explosion, it's cooler. It's hotter at the center, it's cooler at the periphery. So eventually, after this thing goes, it's going to cool down enough that these protons and electrons can suddenly come together, and you have the formation of hydrogen. One proton, one electron, that's hydrogen, and that will eventually become the basic substance of this universe, hydrogen. And as you get farther and farther away from this massive explosion, they're going to coalesce. Now, anybody who's studied some of this stuff in chemistry and physics, you know that when you've got things that coalesce, you get changes in heat, okay? You get a cooling down, these little pockets of cooling down where these things coalesce, okay, where they come together. They're taking energy in and cooling the area around that. And so they said, you know, if this great explosion and you've got this background radiation, we ought to be able to see an evidence of these little cool spots where galaxies formed in the remote past. In other words, and I have to tell you, of all my studying on this, this is the piece I had to just like look at and study the most, because we're talking about something called great galaxy seeds. And that is not something I ever studied before. I'm sorry, great galaxy seeds. This is not something I'd ever studied before until I came across this information in this book. And so I had to go and look this stuff up, and it's really actually quite complex. So I'm really simplifying it here. It's too complex for me, but I want this to have to be generally understood. So we're sitting there looking at a planet that is at a star that's say 10 light years away. We have to remember, if a star is 10 light years away, the light that we see today was sent from that star 10 years ago. It took 10 years for that light to travel the distance to Earth. So when we see that star, we're looking at the past. We're looking at the way that star looked 10 years ago, because that's how long it took for that light to get here. Does that make sense? Mm-hmm. The same thing with this radiation afterglow. When galaxies start to coalesce, and then they have a little bit of a temperature change in the cosmos here. When that radiation and temperature change gets to Earth, we are actually taking a picture of the far distant past, when that galaxy coalesced into one thing. That galaxy's been there for a long time, but we are looking at when that galaxy coalesced sometime in the past. So the physicists kind of looked at that and said, well, we would expect to see this background cosmic radiation, and as we see the cosmic radiation, we would expect to see these little temperature fluctuations in areas where the galaxies coalesced. And so these guys went on a venture, and they built a satellite, and this is it right here, and its whole purpose was to measure the cosmic background radiation and map out the universe in temperature fluctuations to see if it would fit their predictions based on galaxies forming. So this was called the COBE, C-O-B-E, the Cosmic Background Explorer, and that was sent off in 1992. Well, it came back with a picture that looked kind of like this here. And they saw exactly the type of fluctuations in temperature throughout the universe that would be predicted by the coalescence of galaxies. So what you are actually seeing when you see the images from this COBE, what you are actually seeing is the distant past as galaxies formed in the universe. And this guy said this. This is the guy that was heading up the team, named George Smoot. And he said the result of COBE's finding led astronomer and project leader George Smoot to announce, if you're religious, it's like looking at God. These pictures then represent the existence of matter from the very early universe, the seeds of the galaxies as they exist today. These seeds are extremely large, but also extremely exact in allowing galaxies to form. Smoot referred to them as the fingerprints of the Maker.
Just out of curiosity, I don't know whether he was atheist or...
I spent a lot of time looking that up. I did. I spent a lot of time Googling George Smoot and his faith and religious views. And I couldn't find very much.
Okay.
But I will tell you that he's probably not a Christian, but I think that this probably had a radical effect on his view of whether or not there's a theistic God, because he understood the implications.
Very good.
When they say something's 10 light years away, how do they measure that? I mean, how do they know? I mean, I understand the math and stuff in it, but how do they know
They
that
spit
it's
all-
actually 10 light years away?
I'm going to get back to you with that next week, because I can't answer that off the top of my head. But I'll get that to you.
So, I mean, that stuff that we see now has changed for 10 years. So
That's
it's
exactly
totally
right.
different.
It's totally different, and we have no idea what it looks like, because the data we get is 10 years old from a planet from a star.
So it's like watching reruns on.
Reruns are, well, and most things are way further away than 10 million, or than 10 light years.
Right.
I mean, most are millions of light years away.
Because it's places we've never been, so I mean, we don't know exactly that it's that far away. I mean, there's no way that we can.
Well, we can measure, just as an example, we can measure how fast they're moving, though. We can measure that by Doppler effect and the red light shifts, and we know exactly how fast they're moving relative to us.
Right, but we've been to point A and point B. When we're doing this, we haven't been to point B, so
That's
we don't.
exactly right. That's exactly right. That is a scientific calculation. It is not because we've been there.
It's
A
not
little
actual
bit of
direct
theory
measure.
involved in it.
I'm sorry?
A little bit of theory involved in all of it. But the
Yes,
facts,
but no,
facts that came out of it.
well, there's some theory, but there are reproducible and reliable mathematical ways of calculating it that are reliable. So, and that's what I can't.
Right.
That's what I can't answer. But I'm going to look that up, and I'm going to get brushed up on it, and I'll come back with an answer next week.
When the average distance between the stars is 200,000 light years, right? So actually the nearest one that we would see is from 200,000 years ago. Pretty amazing.
Other than the sun, right?
Yeah, the next.
The nearest star to the sun. That's right. So finally, we're going to look at E, which is Einstein's general relativity. So Einstein is developing his general relativity, and this is a theory that kind of pulls together the relationship of mass, energy, and gravity. When you start looking at this, it is really heady stuff. This is something that's way beyond me. But basically, in relating energy and mass and gravity, the equation E equals mc squared, which maybe you've heard of before, but that says that energy is equal to the mass times the speed of light squared. And basically, what this says is that matter has an amount of energy, okay? And that energy, the matter has energy divided by the speed of light squared. And so it has implications for things that travel at the speed of light. And as you read this and as you try to understand it, it gets conceptually difficult. I'll just say that. But let me just tell you the importance and the implications of it. Einstein was developing this theory of relativity, and he realized that his calculations would implicate, with respect to time, energy, matter, that it all had a beginning. And he didn't like that. He didn't like it. He didn't like the implications of there being a beginning. You remember, this is before Edwin Hubble and the red shift. He's in the process of developing this. And so in his calculations, he changed it. He put in an actual fudge factor. He called it the cosmologic constant. And he put this thing in there so that his calculations would not implicate a beginning to the universe. And it was in the middle of these calculations in the development of this theory that Edwin Hubble called him and said, hey, Al, I need you to come check this out. And he showed Albert Einstein what he was seeing in his telescope that showed that as things got farther away, the redshift was greater and greater, which implicated that the universe was expanding. And they both knew that if the universe is expanding, that means that it was at a single point at some point in the past. And Albert Einstein admitted later that one of his greatest mistakes was introducing this constant, introducing this into his mathematics, because he didn't like where it was leading. And he repented of that, and he took that out. And the general theory of relativity does suggest that there was a beginning to the universe, and it fits perfectly well with what we know from second law of thermodynamics, from the universe expanding, from the background radiation, and from the great galaxy seeds. They all fit into a giant, scientific, perfectly meshed understanding of how the universe began.
There's the one we're familiar with.
Is his tongue sticking out like on the billboard?
Yeah.
So, what we have done is simply this, guys. We looked at the argument that says anything that begins has a beginner, or anything that starts to be has a cause. The universe had a beginning, and that's all we're looking at right now, is all the evidence that the universe had a beginning. And there is perfect uniformity and general consensus about this origin. And so the scientific evidence leads actually to a biblical account of creation. Astronomical evidence leads to a biblical view of the origin of the world. The essential element in the astronomical and biblical accounts of Genesis is the same. That's Robert Jastrow, who is an agnostic and the founder of NASA's Goddard Institute of Space Studies. Also, astronomers now find they've painted themselves into a corner because they've proven by their own methods that the world began abruptly in an act of creation to which you can trace the seeds of every star, every planet, every living thing in this cosmos and on the earth. And they found that all this happened as a product of forces they cannot hope to discover. The forces that took nothingness into somethingness is the forces which they cannot hope to discover. That's what he's referring to.
Sounds like Paul's argument. This unknown God.
Mhm.
I know it.
Yeah.
There you go. Amen. Because before all this evidence, most atheist scientists believed that the universe just simply always existed. That it was just always there. And if that was true, if the universe did always exist, then it wouldn't need a creator. Right? If it's always been there, then nothing made it. And really, because a lot of times the atheists will ask you, you say, well, God created the universe, and they'll say, oh yeah, well, who created God?
We're going to get there.
Oh, there you go.
Okay. Thank you. So, finally, that there are what I or anyone would call supernatural forces at work is now, I think, a scientifically proven fact. And we're going to explore that a little bit deeper. But the problem is this, and everybody who's honest about it gets this. We have leapt from nothingness to somethingness at a finite point where there was the beginning, not only of all matter and all energy, but the beginning of time itself. That something outside of time got this ball rolling. And that's what he's saying with that. So if the universe had a beginning, then it must have had a beginner. Because the evidence leads us to the two following options. Either no one created something out of nothing, and that's the atheist view. Or someone created something out of nothing. That's the theistic view. Now, this is where I don't have enough faith to be an atheist comes in. Because the whole idea of no one creating something out of nothing is absurd. By definition, somethingness out of nothingness is outside of nature. Or we would say supernatural. Outside of nature, supernatural. And that is the problem of the faith of an atheist, is they go back to this point and then they say, well, we can't know it. David Hume, Immanuel Kant. We can't know it. Therefore, we just say, it just leapt out of nothing. That takes a great deal of faith. A great deal of faith in your atheism to suggest that nothing could take somethingness out of nothingness. So the question to ask an atheist is, if there is no God, why is there something rather than nothing at all? How does that happen? Well, there are some responses, and we'll get to those momentarily. So scientists state that there was a beginning. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is now no escape. They have to face the problem of a beginning, of a cosmic beginning. And again, I apologize. These slides are perfect on a regular desktop, but then when it transfers to the devices, they don't transfer the same way. Almost everyone now believes, this is Stephen Hawking, that the universe and time itself had a beginning at the Big Bang. And scientists state that the beginning was out of nothing. Arno Penzias, the Nobel Prize winner that we talked about earlier, the easiest way to fit the observations with the least number of parameters was one in which the universe was created out of nothing in an instant and continues to expand. He's being very intellectually honest. He's saying the simplest way to fit the data, to fit what we know into an explanation of the beginnings, is this right here. The universe was created out of nothing in an instant and continues to expand. Scientists also state, atheist Victor Stenger, the universe exploded out of nothingness. Scientists also state, besides coming into existence from nothing, that the beginning was supernatural. Arthur Eddington, the beginning seems to present insuperable difficulties unless we agree to look at it as frankly supernatural. That is what I meant by saying when you get something out of nothing, that by definition is outside of nature. And again, Arnold Penzias, astronomy leads us to a unique event, a past which was created out of nothing, one with the very delicate balance needed to provide exactly the right conditions required to permit life, and one which has an underlying, one might say, supernatural plan. And finally, Robert Jastrow, that there are what I or anyone else would call supernatural forces at work is now, I think, a scientifically proven fact. And again, I just want to point out that these guys are not Christians. Okay, these guys are scientists, and Jastrow is an agnostic. So the question is, with all of that in place and the vast body of scientific evidence supporting a beginning to the universe that was supernatural, how do atheists respond to this evidence? Author of The God Delusion, Richard Dawkins, and I'm so sorry.
That's probably the name he'd like to go by.
What's that?
Atheist Richard.
Yeah.
Atheist Richard. The central argument of my book, which is on page 157 to 58, is that the appearance of design is overwhelming. And we're going to talk about that under the teleological argument. Number two, there's no explanation for it in physics. Okay? The elements of design in the universe cannot be explained by physics. So maybe there's a multi-universe theory, which basically relies on luck. We just got lucky to have just the right conditions here. Let me just make a couple of things here. One of the Terry Sowinski Defense of the Faith, the Terry Sowinski Apologetic, she said, think about every explosion you have ever seen, that you have ever witnessed, that you've watched on TV, and tell me out of which explosion did order come out of chaos? Where did we ever see a giant explosion that didn't destroy, but rather created order and design?
I think that number would be infinite. I'm serious. I don't think that number ever ends. I don't think you could ever have an explosion and out of the explosion create order.
I don't think it's ever happened but once.
Well, but that was through a design by a creator.
Exactly.
The only explosion you really have is a
Yeah.
volcano that
It's
actually
the shortest
can cause
apologetic.
destruction,
Yeah.
but also, you know what I'm saying?
Yes. Okay. So I didn't say that things could not be created out of an explosion. You can get bits of
Oh, yeah.
lava and molten and designs of, shapes of an island. But those are natural forces, not designed forces. The point is that the universe has delicate and intricate involvements that looks clearly designed. And he is saying that the appearance of design in the cosmos, he's referring to the cosmos, not just life on Earth. The appearance of design in the universe is overwhelming, and that there's no explanation for it in physics. And so that's where he comes up with a multiple universe. If you've got enough universes, this is what Chad was talking about. If you've got enough universes just getting spit out by a universe-making machine, eventually you'll get just the right universe with just the right conditions of gravity and galaxies and the distance between stars and planets to allow life to exist, that we could be there. We just got lucky that this one universe out of an infinite number that are just getting spit out by this universe-creating machine. And I have to ask you, what makes more common sense? And also, let me ask you this, is with a multiple universe, who made the universe-making machine? That doesn't make the notion of a maker less easy. It makes it more complex. It says somebody's got to be out there pushing the button to create another universe, this multi-universe.
Well, there's no evidence for multiple universes. That's the other problem. It's 100% fake.
That's his. Yeah.
Because I mean, that's the multi-universe theory is basically the atheist's way to try to get around
The appearance of design.
They're trying to get around it. What they're basically saying is, oh, this universe is just one of an infinite number of universes. And so the reason that we're alive in this universe instead of all the other ones is because we just got lucky. We hit.
We hit the jackpot
This
on
one
just
just
the right
happened.
conditions.
Right. There were some universes that had stronger gravity. So after their Big Bang, there was a big crunch. And everything, or this universe didn't have enough gravity. And so once it banged, everything just drifted apart like ashes. But this universe was the perfect one where things could coalesce and, stay together but not be crunched back again. But there's actually very smart people that believe that. But the problem with it is that's nice, but it's all a fairy tale.
Yeah,
You can make up anything you want.
I want to see
make up in-
Vegas.
Right, but there's there's absolutely no evidence for that. We only
So-
have access to this universe.
So once again, we find a position of faith, blind faith, that says this is more probable than a maker. Okay, and that's why it's called I don't have enough faith to be an atheist, because the amount of blind belief that you have to take something like this is incredible when there's no evidence for it. The reason these theories get put in place is because the true approach is not like the original astronomers that we were reading about what this evidence looks to. What is happening here is people take the approach that says we cannot allow God a foot in the door That cannot be. Therefore, there's no explanation for this, so we get to make up whatever cockamamie idea we can.
Right.
Okay, because we can't allow God a foot in the door. Here's the problem. If you can't allow God a foot in the door, if he's true, if he's real, that's why we started with truth and reality, you will never find him, even with all the science in the world, because you are going to a priori reject that as a conclusion. If you a priori reject it as a conclusion, when you come across something that looks supernatural, you make up a thought like this to explain it.
Right.
And I ask you, what makes more sense to explain what we know?
Well, not to mention that is bad science. If you're doing
Right,
science,
right.
you're supposed to study the
Yeah, prove
evidence
it.
And see
and
where it
follow
leads.
where the evidence
Yeah.
leads.
Exactly.
If you're starting with a conclusion, say God cannot exist, and then you make that's bad science.
And you'll never find the real truth.
You'll never find the
It's like
truth.
starting out a math assignment that says, no matter what happens, 2 plus 2 is not 4.
Exactly.
It cannot equal 4. Now
Exactly.
solve 2 plus 2.
Right. Exactly.
And you look
You
at
have
all
some-
kinds of,
Yeah.
that's
Interesting
exactly right.
variations, and that's what you see.
You get
and,
all kinds of screwy equations.
and they're very, very smart people, but they've got blind spots.
Atheist Christopher Hitchens, author of God is Not Great. So he wrote a book too. There's less than 9 pages on metaphysics. Now, we've talked about metaphysics, and so it's just a really fancy word, and I don't like to throw around lingo like that without some brief explanation. That metaphysics is looking at the overarching explanation for why things are the way they are. They are questions of origin, questions of purpose, questions of destiny, and your worldview, like I have a theistic worldview versus an atheistic worldview, will affect the metaphysics, how you understand your purpose in life and what happens after we die and what the origin of things are. Okay, there's less than 9 pages on metaphysics. Number 1, he acknowledges that the Big Bang is the accepted theory of the origins of the universe. He seems to be saying that the theory works without God, but never really says how. It's one of these, it just is. Oh.
It's like you need the widescreen edition.
And I don't have, I'm not going to be able to get number 3 there. I apologize. The multiverse theory. Multiple universes grow like branches from a tree trunk in a model that allows the universes to just create itself.
There you go. No evidence.
It's sort of like we're brushing our ignorance under the rug of the very early universe. And that's really an honest assessment of these theories like this.
So that's another competing theory saying that the Big Bang, that there was more than one Big Bang, right? That there was multiple.
Well, how do you, there are multiple universes. So the response to this is, number 1, there's 0 evidence. This is purely speculative. And the speculation is born out of the fact that the origin of this universe looks, quite frankly, supernatural. So this is not an evidence-based theory. It is a purely speculative theory when we will not allow God in the door. Number 2, multiple universes would multiply the need for a creator and designer because each one would need creation and the fine-tuning to get it started. Number 3, if it's true, who or what is keeping these universes from colliding into each other? And number 4, it is an atheist admission that the universe is highly designed and that the design is empirically detectable. In other words, they recognize that there is design in the universe. They recognize that there was order that came out of a giant chaotic explosion. They understand that that doesn't make sense. And the fact that they're coming up with something like the multiverse theory shows that they recognize that there is design and that is highly ordered and that is unexplainable by natural causes.
Because design shouts designer.
That's exactly right.
Yep. Amen.
Kenny Anthony, in his book 5 Ways, says, according to the Big Bang Theory, the whole matter of the universe began to exist at a particular time in the remote past. A proponent of such a theory, at least if he is an atheist, must believe that the matter of the universe came from nothing and by nothing. And then another Robert Jastrow quote, the agnostic astronomer and founder of the Goddard Institute for Space Study says this: "For the scientist who's lived by his faith in the power of reason, the story ends like a really bad dream. He has scaled the mountains of ignorance, and he's about to conquer the highest peak. And as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries."
Yep. That's the best quote.
So what have we done?
Told you so.
What have we done today? What we've done is we've looked at the cosmological argument for a theistic God. Number one, that everything that had a beginning had a cause. That is a first order statement. That is non-negotiable. That is something that everybody would agree with. That number two, the universe had a beginning. That was the purpose of today's class, is to say that the universe had a beginning doesn't only come from Genesis 1:1. It comes from all the scientific evidence that is out there, and quite frankly, atheists, I said this at the beginning of class, the Big Bang is the Christian's best friend. Okay? And this is why. This is why. That things like the multiverse theory come out of a real understanding that somethingness from nothingness is by definition supernatural. So we better start speculating about things that are not supernatural. And all these speculations just lead deeper and deeper into supernatural beginnings. The universe did have a beginning. And finally, therefore, the universe had a cause. And it brings us back to something that we looked at last week, and this is what we've been plowing through with these responses and what the scientists say. That number one, we have to consider the universe, and we ask the question, was it eternal? There was no beginning, or was there a beginning? And the answer is the overwhelming scientific evidence says there's a beginning. Number two, that beginning was either caused or it was uncaused. We have no other options. It was either caused or it was uncaused. Number three, and this leads to premise one. Things that had a beginning had a cause. This is not logical. It is illogical. It is simply illogical. And if there was a cause, either it was a personal, supernatural, outside of nature cause, or it was an impersonal, natural cause. And there is nothing in nature that any one of us knows or understands or has ever witnessed where something natural could have something come from nothing. The only logical conclusion from all of this is that there was a personal, supernatural beginning to the cosmos. It is the only logical conclusion. And that is the end of the first argument. And next week will be the teleological argument from design. Any questions?
Great, Jim.
I just want to say, I had my numbers wrong, I forgot. The average distance between stars isn't 200,000 light years. If you got in a space shuttle traveling 5 miles a second, the average distance would take you 200,000 years.
Right,
That
right.
was, I had the number wrong.
But look, stars are really far apart.
Yeah, even when you slice it.
Okay. So when you start looking at the size of this universe, it's mind-boggling. So what Joe is saying is the closest star at 5 miles a second, the space shuttle travels at 22,000 miles an hour. Okay, that's how fast a space shuttle can go. So you hop in your space shuttle and you get to going. It would take you 200,000 years traveling at 22,000 miles an hour to get to the closest star, our sun.
You got
200,000 years at 22,000 miles an hour to get to the closest star. That's one star. One star. Think about the Sahara Desert. 200,000 years to get from one grain of sand to the next grain of sand, and you got the whole Sahara to explore.
So it's impossible for us to know what the universe really looks like right now.
I would say that that is an eminently true statement.
You don't get there and it's not gonna be there anyway, so it doesn't matter. That's already happened 200,000 years ago.
Anything else?
Are you eventually gonna address like how this relates then to Genesis? Because there was that nice quote that basically said that it confirms Genesis, but obviously it looks a little bit
I
different.
wonder how the people at the Creation Museum would go with this. 'Cause they don't think it.
Right, there's,
4,000
years.
right, right.
So here's the thing about that. I said at the beginning that my goal is not to get into young Earth, old Earth views. And if you ask me my views, I'll tell you them. But I think that that type of a question, because these are strongly held beliefs, I am simply looking at this from a scientific point of view, not from a personal agenda point of view. I personally am an old Earth. I have an old Earth view, and I think that the Bible is the infallible Word of God. I don't think there's any fallible. But a belief in a 7-day creation is fine. I have no objection to it. But that system requires that we do interpret day to mean 24 hours. And my response to that would be, Scripture itself says, a day is 1,000 years, and 1,000 years is a day to God. And the word day that's used in Genesis is used all throughout the Bible to say, in my day, we used to do this and that, meaning in my era, in the era that I was existing. So that is completely understood to say, in the first era, this is what happened. In the second era, this is what happened. In the third era, this is what happened. The reason that people understand it as a 24-hour day is because it says, and there was evening and there was morning, the first day. It seems to be discussing 24-hour things. The book of Genesis was not written as a scientific treatise. The book of Genesis was written to explain the origins. And so it is something that, I mean, the Jews are writing in terms and words that are sometimes history, sometimes allegory, sometimes metaphor, sometimes simile. And I read Genesis, and it has actually a very excellent correlation between where things started and how we understand them to have come about on Earth. Very close. Where waters come in is where waters come in. Where sea life comes in is where sea life comes in. Where land animals come in, land animals come in. There is an excellent correlation between the two. Excellent correlation. Whether you think that's 7 days, or whether you think that's, thousands or billions of years, doesn't matter. Doesn't matter. The bottom line is simply this, that there was nothing, now there's something, and that is a scientifically proven fact. And we got to explain that.
Right.
That's the bottom line.
And God created it all in an orderly fashion, step by step.
That's sure the way it appears. And we're going to get into that next week.
Thank you.